Today's topic of discussion is Hallwach and Lenard's observation regarding photoelectric effect. Okay, now see Lenard's experiment. First of all, we shall discuss. The figure is showing two metal electrodes which are kept opposite end. Okay, inside the evacuated glass tube. So there are two metal plates. Okay, they are kept at opposite ends inside the evacuated glass tube. This is the evacuated glass tube. Now one electrode is called the cathode, that is emitter, okay, with the photosensitive surface, and second electrode is called the collector. So this is the collector and this is the emitter, or it is called also as cathode. Okay, now a quartz window is provided in this tube. This is the quartz window which is provided here in this tube, through which the ultraviolet rays are incident on the cathode. So ultraviolet rays are incident on cathode via this quartz window. Okay, so these are the ultraviolet rays which are incident on cathode. When ultraviolet rays are incident on cathode is stopped when current in circuit will become 0. Okay, what will happen now? Whenever the ultraviolet rays are incident, then if they are of proper frequency, then the photoelectrons are emitted. So when ultraviolet rays are incident on cathode is stopped when current in the circuit will become 0. Anode is kept at positive voltage with respect to cathode, hence it attracts electrons emitted and there is flow of electron, hence current flow in the circuit. So whenever the ultraviolet rays are absent, the current is not there, but when these ultraviolet rays are incident on the cathode, then these photoelectrons are emitted. They will be attracted by the anode. Okay, it is generally kept as positive potential. So electrons are attracted by this positive potential and they will produce the electric current in the circuit. Okay, a quartz window is provided in this tube through which the ultraviolet rays are incident on this cathode. Now see, when ultraviolet radiation is stopped, current flowing through the circuit will also stop. Lenard studied how photocurrent changes with collector plate potential with frequency and intensity of incident light. Now this Lenard has changed the different values of voltage. He has changed the potential of the collector with respect to the cathode. He also changed the frequency of ultraviolet ray. He also changed the intensity of ultraviolet ray. Now Hallwach experiment. He connected electroscope with negatively charged zinc plate, which is shown in this figure. See, this is the zinc plate which is negatively charged. Okay, and it is connected with the electroscope. So electroscope determines whether there is charge on the zinc plate or not. Now his observations are like this. When ultraviolet light was incident on zinc plate, it lost its charge. Try to understand. Zinc plate is already negatively charged. It is connected with the electroscope. So electroscope shows that it is charged plate. Now when ultraviolet light is incident on zinc plate, then electrons are emitted. Photoelectrons are emitted. So there is a reduction in the electric charge or other negative charge, which can be again shown or seen from the electroscope that it has lost the electrons. Okay. Initially, when ultraviolet light was incident on chargeless zinc plate, it became positively charged. Say if you take the chargeless zinc plate, if there is no negative charge, and if you incident this ultraviolet light, then this becomes positively charged, means electrons are emitted, so zinc plate becomes positively charged because it has lost the electrons. When initially zinc plate was kept positively charged, if you have kept this zinc plate as positively charged initially, and if you incident this ultraviolet light, then what will happen? It will again lose the electrons, so it becomes more positive. Okay, so positive charge on it increases. From these observations, he concluded that when ultraviolet light is incident on zinc plate, negatively charged particles are emitted from the plate. He also concluded that when frequency of incident radiation is less than some minimum frequency, photoelectrons are not emitted. So it requires a minimum frequency. That frequency radiation must be present, otherwise the photoelectrons will not come out from the zinc plate. Now we shall talk about the threshold frequency and on which factor threshold frequency depend. See, in previous topic we have discussed that we require a particular minimum frequency for the beginning of the photoelectric effect. That minimum incident frequency required to emit the electron from the metal surface is called the threshold frequency, and it is denoted by nu 0. Now this value of threshold frequency depend on the type of metal. For most metal like zinc, cadmium, magnesium, this threshold frequency is in the region of ultraviolet light frequency, okay, which have shorter wavelength. For some alkali metals like lithium, okay, sodium, potassium, cesium, rubidium, this threshold frequency is in the visible region. Now there is an experiment to study the photoelectric effect. This figure shows the metal plate that is cathode, as I have explained earlier, okay, and the other one is the anode, or we can say it is a collector, which are kept at the different ends in the evacuated glass tube. So this is the cathode, this is anode. There is a quartz window, okay, the source of radiation is kept. This is photosensitive plate, which is cathode, okay. Now there is a four-way key, okay, it is a commutator as such. Now this can help to join this C with positive terminal of battery as well as with negative terminal of battery. When this C, that is cathode, is connected to positive terminal, then automatically this will come to negative terminal, that is the collector, okay, or anode. And if you connect this with negative terminal of battery with the help of commutator, then this anode will be connected to the positive terminal of the battery. So by using this, we can change the polarity of the connection, okay. There is micro emitter joined in this circuit which measures the electric current, okay, and from that we can find out the number of electrons which are flowing in the circuit per second, and we can measure the potential difference between the C and A with the help of voltmeter, okay. This way the circuit is connected. Here rheostat is also connected, and with the help of this rheostat we can change the value of voltage, and simultaneously there will be an effect in the electric current which is flowing in the circuit. Okay, so this is the experimental arrangement. Okay, potential difference between emitter and collector can be measured with the help of voltmeter that I have told you, and here micrometer is used to measure the electric current, and with that current we can find the number of electrons which are flowing through the circuit per second from a particular cross section. Now by changing the photosensitive surface on plate C also can be changed, and change in the photocurrent can be studied. You can change this photosensitive surface. Say for example, initially you have kept say zinc, then if you want to change it and this photosensitive surface we want to make say that of copper, then this photosensitive surface can also be changed here at point C, or cathode can be changed as per the requirement. Okay, intensity and frequency of radiation incident on the plate C can be changed. Okay, in this, and what will happen, the photoelectric current will also change or it remain constant. That also is the procedure which is followed in this experiment. Okay, filter or colored glass of different color can be placed between plate C and path of incident radiation, and light of different frequencies can be used. Say for example, here if you place say red colored plate or red colored glass, then the frequency of incident light will be that of the red color. So this way you can change the frequency by placing the different color glass in between the rays of incident light, or so say source, and the and the what you call it, the photosensitive surface. By changing distance between light source and plate C, by changing the distance between light source and plate C, we can change the intensity. Say for example, if this source is close, then intensity will be high. If this source is away from this what you call it, cathode, okay, if this distance is more, then the intensity of light will be less. So this way the intensity of incident light, okay, then frequency, okay, then potential difference between C and A, that can be changed. Okay, then by changing potential difference, what is the change in electric current, that can also be measured. So different parameters can be changed in this experiment, and effect on the number of photoelectrons which are emitted from C can be seen with the help of this micrometer. Okay, now first effect is of variation of intensity of incident radiation on photoelectric current. Now see, collector is kept positive with respect to emitter, that is cathode. So cathode is kept say negative and collector is kept positive. Okay, so say this is your collector, as rather cathode, and this is the collector, that is anode. Okay, now here the light is incident. Now first you are keeping the collector as positive and the rather cathode as positive and collector as negative. Okay, collector is kept, rather opposite is it is kept. Say for example, this you are keeping say positive, and the cathode on which the radiation is incident is kept negative. Now what will happen, electrons are emitted, that is photoelectrons are emitted, and they will easily be attracted by this collector, okay, or we can say anode. Anode is a collector, okay. Cathode is a photosensitive plate. You are incidenting the radiation of proper frequency on photosensitive plate. So what will happen? Electrons are emitted and they will be attracted by this collector, or we can say anode, that is kept at positive terminal of the battery, or it is joined with the positive terminal of battery. By keeping frequency of incident radiation and voltage on collector constant, this frequency you keep as it is, okay, then voltage of collector you are keeping as it is, intensity of incident radiation is changed. Now what you are changing? You are changing the intensity of radiation which is incident on this photosensitive surface. So you are changing the intensity. So either you are increasing the intensity or decreasing the intensity. Then what happens? If you are increasing the intensity of radiation, more intense light you are increasing, or we can say the photosensitive surface is illuminated with higher and higher intensity radiation, then the number of photoelectrons which are emitted will increase, or we can say the photoelectric current which is measured by micrometer simultaneously increases as you are increasing the intensity. It means that more intense light increases the number of photoelectrons emitted by the photosensitive surface. The graph which is shown here gives the clear picture that as intensity of radiation is increased, then photoelectric current also increases. There is a linear relationship and we get a straight line for this, okay. Now photoelectric current is proportional to the number of photoelectrons emitted. More the photoelectrons are emitted, more the photoelectric current, okay. So that is seen with the help of this particular graph, okay, and from this experiment, that as intensity of light incident on the photosensitive surface increases, the photoelectric current also increases. Now explain the effect of potential on the photoelectric current in experiment of photoelectric effect. Now see, in experiment of photoelectric effect, collector A is kept at positive potential. So wherever the electrons are attracted, that plate, say this is your plate A and this is the plate C on which you are incidenting the the radiation of proper frequency. Now this A is kept positive. So electrons which are emitted can easily be attracted by A, or we can say collector. When magnitude of positive potential is increased, photoelectric current also increases because it attracts more electrons towards it. For particular voltage on plate A, all emitted electrons will reach to collector and current will become maximum. Say for example, here you are increasing the potential on this collector A. Now you have increased the potential. Say for example, you have joined the battery here. With the help of commutator that can be done. So here positive potential is there, you are changing it with the help of rheostat. Now that positive potential is say some particular value where the number of electrons which are emitted from the photosensitive surface, they all are reaching to this collector, okay. And when this particular phenomenon occurs, at that time whatever number of electrons which are emitted, they are reaching here. So what will happen? the photoelectric current in the circuit will become maximum. Okay. Now if collector voltage on collector is increased, now say what you are doing now, if collector voltage on the collector is increased, photoelectric current will not increase. After that, what will happen? If you go on increasing the value of the collector voltage, the number of electrons in the circuit are not going to increase, because whatever number of electrons which are emitted from the photosensitive surface, they all are reaching to the collector. So now if you are increasing the value of voltage after that particular maximum value of the voltage, okay, you go on increasing, but the current in the circuit becomes maximum, and that is called the saturation current, where now the current will not increase in the circuit. For value of given collector potential, photoelectric current becomes constant is called the saturation current. So this current is called the saturation current. Now collector voltage is sequentially decreased and made negative. Now what you are doing? You have a collector voltage which you are now making it negative. So what is the procedure? Negative terminal is as if joined with the collector. Okay, this is your photosensitive surface. You are incidenting the radiation on the photosensitive surface. Now you are first making it 0 and then you are making it negative, means now negative terminal has been joined with the collector as if, okay, and now you are increasing the potential in the negative direction. Okay, so electrons which are emitted will be repelled by this. Okay, so some electrons which are having sufficient energy will only reach to the collector. All the electrons will not reach. Those electrons are having less energy will go slightly and then they will come back and again they will try to go. But some electrons which are highly energetic can reach to this particular collector and they will produce the electric current, and that current will be very less. And now if you are increasing the value of negative potential on this C, that is collector, then what will happen? The electric current gradually decreases and becomes 0. Okay, when now collector voltage is sequentially decreased and made negative, there will be repulsion between the electrons and negative voltage of the collector. Okay, when collector voltage is made more negative, repulsive force will be increased. Okay, and electrons which are having sufficient energy or energetic electrons will only reach to the collector. Value of collector current will sequentially decrease. Okay, value of negative voltage on collector for which photoelectric current becomes 0. Now what will happen at a particular value of negative voltage? This photoelectric current is going to become 0. This is called the cutoff voltage or stopping potential, and which is denoted by V0. It is denoted by V0. Energy of all electron emitted from metal surface are not equal. Try to understand the electrons which are emitted from photosensitive surface. They all are not having the same energy. Stopping potential gives idea of maximum kinetic energy of the photoelectron. So up to that potential some electrons were reaching, so they were having the maximum kinetic energy, we can say. So and if that potential, that is V0, is brought or reached, that on the collector they stopped coming, it means that much amount of energy the electrons were having earlier, and that is giving you the idea of maximum kinetic energy. Okay, for photoelectric current to become 0, okay, this potential has to be brought, or this is the potential at which the photoelectric current becomes 0. So at up to that the electrons were coming, means they were having maximum kinetic energy, and therefore maximum kinetic energy of photoelectron is equal to energy of electron at this potential, that is V0. So equivalent energy can be written as K max is equal to EV0. In this experiment, when frequency of incident radiation is kept constant and intensity of radiation is changed, say frequency is kept one frequency was fixed and intensity you are changing to I1, I2 and I3. Okay, where I1 is less than I2, I2 is less than I3 means in increasing order the intensity is, that is I1 is less, I2 is more than I1 and I3 is again more than I2. Okay, what happened? The photoelectric current versus stopping potential graph is shown. Photoelectric current, this is stopping potential. Okay, you are increasing the intensity but the stopping potential is found to be same. Photoelectric current has increased. As intensity increases, photoelectric current increases, but the energy of electron does not increase. Okay, they are stopped at a same potential. Graph shows that with increase in intensity, saturation current increases. That is, more number of electrons are emitted with intense light. Thus, number of photoelectrons emitted per second increases with increase in intensity of incident radiation. From graph, it can be said that for given frequency, stopping potential do not depend on intensity. You go on increasing the intensity, but the stopping potential for a given frequency, for a constant frequency, is going to remain constant. Stopping potential does not change with frequency. Thus, maximum kinetic energy of photoelectrons depend on frequency of incident radiation but not on the intensity. Higher intense light does not give more energy to the emitted photoelectron. That can be concluded in this particular experiment. Okay, thank you very much. Watch this 2-3 times and refer the textbook. Okay, thank you very much.